Before getting fully involved with curves, let's add another factor here. It's kind of like juggling. Let's add another ball to our juggling act, and that ball would be color space. If we come up here to the word image and go down to the word mode, the color spaces I'm concerned with are RGB color, CMYK color, and LAB color. Those are the three we're going to talk about. All three have advantages, pros and cons, if you will, on why you might want to use them or why you might want to use another one. Let's start with, let me get out of here. Let's start with RGB. RGB is defined as additive color. Additive color is the color space of your monitor, your television, typically your digital camera. It is the most popular and widely used color space in Adobe Photoshop. Its advantage is it's a relatively smaller file size and it has a very large gamut, lots of colors, which means it's easier to use RGB to repurpose an image to go to CMYK, which has a smaller gamut, less color, or something like the web, which obviously has much less than that. The colors, of course, are red, green, and blue. Notice the complementaries. If you mix blue and green, you get cyan. If you mix blue and red, you get magenta. And if you mix red and green, you get a pure yellow. If you mix all the colors together, you get a pure white. Think of the word additive. What we're really saying is we don't really need a light source to make this happen. You could turn off all the lights in your room and your monitor would still show you color. The opposite of that is CMYK. Cyan, magenta, yellow, and the fourth K for black. You'll notice the opposite colors are true here too. If we mix magenta and yellow, we get a red. Yellow and cyan a green, and cyan and magenta a blue. Subtractive color is the opposite of additive. It requires a light source. You could go into a room without any windows and turn off all the lights and you wouldn't be reading much. But if you turned on a light, the light source strikes the paper. This is the world of paper. Light source strikes the paper. The inks will subtract color based on what they absorb, and what's left comes back to your eye. Although this is a smaller gamut of color, which means it would be difficult to color correct a CMYK image if you were planning on taking it to RGB, many people who work in the press industry are much more comfortable color correcting in CMYK simply because that's where they live. That's the CMYK. The third one is LAB. LAB color is device independent, which means it has no problems moving between operating systems or applications. I use it a lot if I'm working out of the CMYK world and I'm just doing some simple prints, but I'm moving those images between a lot of different systems, maybe different operating systems, Windows to Mac, or different programs. I'll never have a problem. It's a 3-channel system. L, which stands for lightness or luminosity, goes from black to white. The A channel switches from cyan to magenta, and the B channel goes from blue to yellow. I have done color correction using LAB, and I do like it, but it's very, very sensitive to very small changes. So you have to really watch it if you're going to use the space. One thing I do use it for, I find myself using it a lot, is when I'm adjusting things like exposure or getting rid of artifacts that are created by digital cameras. It can help you there too. Those are the 3 main color spaces. I would like to show you one more thing here, and that is bit depth, channel bit depth. You go back up to the word image on the pull-down menu, and you go down to mode, and you have 8, 16, and 32-bit channels. Let's not even worry about 32. Let's concentrate on 8 and 16. What does that mean? What do they do? It's all about color, how much color you have. If you work with 8-bit channels, you will get the ability to modify each one of the colors in 256 steps. So there's 256 steps of red and green and blue. That's not really a lot when you think about it. However, if you multiply 256 times 256 times 256, you get 16,777,216 colors. That's a lot of color. However, if you go into 16-bit, each channel can produce 65,000 possible variations of each color. You take 65,000 and multiply it times itself, you literally get trillions of colors. Most photographers, if you're out there, shoot raw and shoot in 16-bit. We'll bring it down to 8 later, but understand you have much more control over the color in an image if you're working in 16-bit. It's easy to figure out where you are just by looking right up here. This is an 8-bit image and it's in the RGB color space. You make any changes to anything here and it will reflect itself right over here.